Hello. We will begin our next lecture with working with simple variables. To be able to access the files for this session, you will need to visit github.com/binblockchain/CBC2020, and you will see essentially all of the files I will be using. And we will start with simple variables. I do have access to this repository, but you can actually use this without having any kind of GitHub account. You can, of course, clone it by using pull requests, but the easiest thing you can do to actually have access to the files is open a simple file like this one, simple variables, and then just copy and paste with Control-C the code. And then I will go to Remix, create a new file, which I will name simple variables.sol, and I will paste the code here. So let's take a look at what happens with the Solidity code at the moment. The first phrase, pragma solidity, actually declares that this is a Solidity file and also declares the version of the compiler that this contract has been written. Let's go and change 0.64 to 0.6.0. And remember always that you need a semicolon to terminate. Then we have the declaration of the name of the contract, and you'll see there is a typo here, so this should be simple variables. Then I have curly brackets. And you'll see that any kind of line that is preceded with 2 forward slashes are comments, right? So these are here as comments to be read by humans, and they are not taken into account from any part of the compiler. So as we discussed, contracts are essentially classes that run on the EVM machine, and classes would contain variables of various types and functions. We see here a bool variable, which is public, so it's accessible from outside the contract, and the name of the variable is my bool. And this essentially will oscillate between 0 and 1. And then I have a function which is associated with this variable called setMyBool, where I declare essentially the variable that it's public, and I equate the name of the variable with the function inside it. After the Boolean variable, we will see the integers, right? And Solidity can take various sizes of integers if they are undeclared. And when I say undeclared, I mean like this, without a number, say 8 or 64 or 256. Essentially, at 256 unsigned integer is meant. And here I declare again the type of the variable, whether it's public or not, and the name, and then it follows a function where I set essentially the declaration connecting the myUint with _myUint. Be careful with the integers, because one of the problems is that they wrap around the numerical boundaries, and once they reach the boundaries, they return to the beginning or end, the other end, right? So note the increment and decrement functions within integers. And to do that, we can declare an integer here, which is called myuint8, and a function that essentially increments the myuint by a certain number, here by 1, and here by minus. And once we compile and play with the contract, you will realize what the wrapping around means. Another important variable are obviously addresses, and addresses either refer to the address of an account on Ethereum or the address of a contract. Here it is meant that we declare an address of an account, of a normal account, and of course we also have the function that again follows the same pattern, set my address, where the variable and the connection inside the function are declared. As an aside, where only the address of the variable is declared, we can also have various other information attached to an address. For example, a balance of an account. And we close the very simple understanding of variables by working with strings. So string is essentially a sentence. And you see here that I have declared a string which is public, and I've named it my difference, because originally we were trying to use this contract to establish the difference of hashes between two different files on IPFS. We'll see at IPFS how IPFS can work with this at the last lecture. And follow on from the variable, I have a function which essentially sets, again, the mechanisms of how we will connect a string, which, be careful here, it is declared where it lives in memory and not on permanent storage on the EVM. And then the mechanism of how I will connect through the function to setting up the string. Be careful also that this variable here is started with an immediate initialization, so I actually assign a value to it, which is this is an IPFS hash, but I can also change it to CBC2020 is exciting. Okay, so I have this contract at the moment. I can go here, and since I have 0.6.0, I will change this particular compiler to this one and compile, and immediately I have this ready. So I can go here. I have no deployed contracts yet. I'm still just using the JavaScript EVM, and I will deploy. See, that happens immediately. And you see that I then have all of these available as buttons, so I can set various options on it. So let's change the address, and let's take the second one. And I copy it by clicking on this button here, and I will go and paste it and click on set my address. And you see that a transaction is triggered, and let's go take a look. And sure enough, this is the address I assigned here. Let's see what my bool is. It is set to false. So I write here true, and you see that I get it set to true. Set my difference. This is a string, and let's write that the weather in Aberdeen is great today. At the moment I set this, you will see that the string is set to the weather in Aberdeen is great today. Let's take it to the original that I've set, which was CBC2020 is exciting. And sure enough, the moment I run the transactions, this changes on the contract. Again, remember, if you're running this either on an injected Web3 through MetaMask or a Web3 provider where you might be using Ganache, you will need to approve the transactions so that gas is paid. So I'm using JavaScript at the moment so that I don't delay the way I can set those variables. Let's take a look at these. So decrement the uint and increment the uint just by looking first at what is the initial value, and the initial value, since we haven't initialized this one, you see that it's not initialized, it is set to 0. Let's take it to 12, and sure enough 12 appears as soon as I set it, and let's increment it by 1, and a second time, and it seems that is not working. Give me a second to figure out why. Sure enough, I was referring to the wrong integer. Essentially, the increment uint and decrement uint refer to uint 8. And the way this works, if you check at the moment 255, and I go decrement twice, I will get 253. Increment once, 254. Increment twice, and the uint has wrapped around the edges. We'll see through exceptions how we can take care of that in a next lecture. So this concludes essentially the way we can set very simple variables to play around with the code. Just download it or pull it through the GitHub repository and do this. Try changing the names of the variables, following on by setting a new name for the function and for the way that the variables are connected within the function. Compile your contract, deploy, and try to set the next values for this particular contract. See you on the next lecture.